Hey everybody, we're going to talk about the law of cosines, which is section 3.2. Okay, the setup is the same as the setup for the law of sines. Okay, and you're going to need the law of sines for this section, so make sure you watch the 3.1 law of sines video first. Okay, so you have a triangle labeled with the lowercase letters as the angles and the uppercase letters as the side lengths. Okay, so there's a lot of different versions of the law of sines. These three are for when you know one of the angles and you want a third side, right? That's why they're solved for like this. And these three are for when you know all three of the side lengths and you're trying to find one of the angles. Okay, you can find all of these versions of the law of sines in your textbook. You can also find them online. Okay, so let's do an example of how you can use them. Okay, so this is an example where we have all of the side lengths. So we have these three side lengths, 11, 15, and 21. Okay, and we want to find out the three angles that go with this. Okay, now what's important when you get started is that you start by getting the angle that corresponds to the longest side, right? So of these three, we can see that this is the longest side. Excuse me. And we're going to find the angle C that corresponds to this, okay? So when you look at the cases where you have all three sides, we're going to do the one where we're looking for angle C, which is this one here, okay? So we would say cosine of angle C is a squared plus b squared minus c squared over 2ab. Okay, and then we're going to fill in our values for a, b, and c. Okay, now obviously you're going to need a calculator for this, and to find the angle C, remember you'll need this function from your calculator. Okay, so when you do that, you should get that C is approximately 106.7 degrees. Okay, now we have three sides and one angle. Okay, so at this point, people usually use the law of sines to continue. You certainly could use the law of cosines 2 more times to get the other two angles, okay, but people usually switch to the law of sines, okay? So now we have the angle C, so we're going to compare the one where we know everything, which is C, to one of the ones that we want to know something about. Okay, and now it doesn't matter if we do A or B, so we'll just pick A. Okay, and now we're going to fill in all the values that we know. So C was 21. Angle C was 106.7 degrees. Okay, side length A was 11. And the angle A is what we're looking for. Okay, so we're going to solve for sine A here. Okay, cross multiply and then divide by 21. Okay, so again, we're going to use our calculator to get an approximate value, and we would get that A is approximately, what did I get? 30 degrees. Okay, now to find the last angle, right, you can just say that you are looking for an angle that adds up to 180 degrees, right? So you would have 180 minus 106 minus 30, okay? So you should get 43.3 degrees, okay? And that's an approximate value, okay? Now, we found out yesterday, or in the previous video, that when you have only one angle, like we do here where we only have C, this is the ambiguous case, okay? So you might check here if it's possible to have a different triangle. Well, if C is 106 and A is 30, right, the coterminal angle for A that has a reference angle of 30 degrees would be 150, okay? You can't have one angle that's 150 and one that's 106 in the same triangle. So there's no issue with the ambiguous case, okay? And that's the reason that we find the biggest angle first, okay? Is actually to rule out the cases when we don't really have the ambiguous case. Okay, let's look at another example like that. Okay. Now, for this example, this is the longest side, so we're going to start by finding the angle A. So we'll have sine of A is equal to, thank you, I'm sorry, cosine of A, this is the law of cosines, is equal to B squared plus C squared minus A squared over 2BC. Okay? So we're going to fill in all the values that we know. Okay, and now we're going to plug this into our calculator. So this will give us A is approximately 97.2 degrees. Okay, now because this angle is obtuse, right, it's bigger than 90 degrees, you can't have the ambiguous case, so we don't need to worry about that. Okay, now I want to point out something about this example. Side B and side C are the same length, right? This is an isosceles triangle, okay? That means that angle B and angle C are the same length, okay? So, okay, we know that B and C are the same since this is an isosceles triangle. Okay, so what we can do is just do 180 minus 97.2, okay, and then divide it in half. Okay, so this will give us each of our angles B and C are 41.4 degrees. Okay, and again, we don't have to worry about whether there's another triangle with this because the angle A is larger than 90 degrees. Okay, so that's how this works when you have all three sides. Okay, let's do an example where we have two sides and an angle. Okay, so we have one angle A and two sides B and C. Okay, now you might be wondering, why don't we just use the law of sines with this? Well, we can't because we don't have an angle that's across from a given side. That's what you need for the law of sines, an angle that's across from the side, but we don't have that. So we're going to use one of these three formulas, okay? And we're going to pick it out based on which angle we know, right? So the sides we know are B and C, okay? And the angle we know is A. So we're going to use this first one here, okay? Oops, cosine of A. Okay, and we're going to fill in our known values. Okay, and this will give us our value for A. Okay, using our calculator, we get that A is approximately 10.7. Oops, big A, the side length A. Okay, so now we have all three side lengths and we have one of the angles. Okay, so now we do have a side length that's across from an angle, and we're going to switch to using the law of sines. So we're going to use the one where we have the side length across from the angle, which is A, and then we're going to do one of the other sides. It really doesn't matter which one, so we'll just do B. Okay. Again, you don't have to worry about the ambiguous case because we have one angle that's greater than 90 degrees. Okay. All right. So we're going to fill in everything we know here. We know that A is 10.7. We know that angle A is 110. We know that side length B is 6, and we're looking for angle B here. Okay, so we would cross multiply. Okay, and then divide by 10.7. Okay, then we're going to use our calculator to get the approximate value of B. So B would be approximately 31.8. Okay, and then we can subtract from 180 to get our approximate value for C, which is 37.9. Okay. All right, let's do one more example like that. Okay, now we certainly could use the law of cosines here. We have two sides and an angle, okay? But maybe easier than that would be to look at this and say that this is an isosceles triangle, right? These two sides are the same length. Okay, which means that angle A and angle C are the same. Okay, so we would just do 180 minus 125 divided by 2 to get each one of these angles. Okay, so we would get 55 over 2, which is, oh, I'm sorry, thought I had to sneeze there. 2 goes into 5 twice, 15 is 7.5. Okay, so both of our angles, A and C, are going to be 27.5. Okay, then we still need to find our side length B. That's the only thing we're missing, right? Now we have all three angles and we have two side lengths. Okay, and we're just going to use the law of sines to do that. Okay, again, we don't have to worry about the ambiguous case because this is an angle greater than 90 degrees. Okay, so I'll just do A over sine A Okay, and we want to compare that to side B over sine B. Okay. Now we know the side length A is 37. We know the angle A is 27.5. Okay. We don't know side length B, and we know that angle B is 125 degrees. Okay, so we're just going to multiply both sides by sine of 127 degrees or 125 degrees. Okay, and then we're going to plug this value into our calculator. Okay. And this would give us B is approximately 65.6. Okay, so again, we could have just gone straight forward and used the law of cosines based on the fact that we have two sides and an angle, but we can also be clever and notice that this is an isosceles triangle and save ourselves some work. Okay, that's really all there is to the law of cosines. So if you have any questions about that, come by the Zoom meeting and I'll see you guys soon.